Every time a cloud passes over a massive solar farm, or the wind dies down in a coastal turbine field, a ghost haunts our power grid: intermittency. For decades, the energy transition was a hardware problem. We just needed more storage. But in 2026, the game has changed. It is no longer about how many electrons you can hold. It is about the secondary brain governing them. In Asia, where 69% of the world's batteries are born, a software revolution is taking place. From shipping containers storing 9 megawatt-hours of power with zero degradation to algorithmic doctors that predict battery death with 1% accuracy, the smart power tech of the East is now the global benchmark. Today, we're going deep into the AI-optimized batteries, transforming Asia's energy grids. To understand the future of energy, you have to follow the data. As of late 2025, Chinese battery giants control a staggering 68.9% of all global electric vehicle battery installations. CATL alone holds over 38% of the market, followed by BYD at nearly 17%. But the real story isn't just manufacturing volume. It's the pivot from hardware to battery management total solutions. While manufacturers like Panasonic struggle with price competitiveness in the LFP market, South Korean leaders like LG Energy Solution and Samsung SDI are positioning themselves as premium software providers. They are building Battery of Things, BOT ecosystems, that manage a battery from its first charge to its final recycling phase. This scale provides a massive advantage: hundreds of millions of operational hours used to train neural networks that can now identify failure modes before they happen. Traditional battery management systems, or BMS, were simple. They just made sure you didn't overcharge. Modern AI-optimized systems are sophisticated computing platforms. They solve the most difficult problem in electrochemistry: nonlinear degradation. The key metric here is state of health, or SOH. It's fundamentally defined as the ratio of the actual capacity to the rated capacity. SOH equals C actual over C rated. To calculate this in the real world, Asian researchers from institutions like the City University of Hong Kong are using long short-term memory (LSTM) networks to capture the life story of a battery. They also use convolutional neural networks, CNNs, to analyze heat gradients, optimizing cooling systems based on predicted heat loads rather than just reactive sensors. This proactive management can extend a battery's usable life by up to 5% over a decade, a massive financial gain for grid operators. South Korea is pushing for absolute precision. In 2024, LG Energy Solution launched their BMTS brand, Be Around, which has a computational capability 80 times greater than conventional systems. Their degradation prediction software has reached an error margin of just 1% to 2%, while the rest of the industry is still hovering at 5% to 7%. How do they do it? Through 3 proprietary technologies. FIRISM. It assesses degradation at the component level: the cathode, anode, and electrolyte. LL Laser. It incorporates electrochemical mechanisms and user-driving patterns to reduce uncertainty. BLISS. A multifaceted diagnosis tool that provides a highly precise health report. For everyday users, this tech lives in their Be Life Care app, letting drivers see their range and energy efficiency in real time, influenced by their own charging habits. If you want to power a city, you need scale. CATL's Tenor Stack is the world's first 9 megawatt-hour ultra-large capacity storage system. One single container can charge 150 electric cars or power an average household for 6 entire years. The engineering here is a marvel. It features a 2-in-1 design that stays under 36 tons, meaning it fits transport regulations in 99% of global markets. But the AI layer is the real star. It manages zero degradation protocols, using overhead thermal management to keep cells in a perfect temperature range, ensuring no capacity loss for the first 5 years of operation. Plus, its upgraded gas sensors are 40% more sensitive, triggering fire suppression 35% faster than previous models. We are seeing these systems deployed across Asian megacities. In Singapore, Jurong Island has become a low-carbon living lab. It hosts a $285 million storage project using Huawei's Smart String platform to mitigate solar intermittency in the tropical climate. They're even piloting vanadium redox flow batteries from NTU spin-off V-Flow Tech, which use massive liquid tanks to scale power from megawatt to gigawatt-hour levels. Meanwhile, Japan's Yokohama Smart City project was a foundational experiment involving 34 firms like Hitachi and Panasonic. They used storage battery SCADA to bundle 2,000 electric vehicles and thousands of home batteries into a single virtual power plant. This collective management reduced peak power consumption by 22%. As batteries get smarter, they also get more regulated. China recently implemented the GB 38031 2025 standard, the strictest battery safety mandate in history. It requires that a battery must not catch fire or explode for at least 2 hours after a thermal incident, giving passengers plenty of time to escape. But all this AI requires data, and that data is now a geopolitical asset. China's energy sector Data Security Management Measures 2025 classify energy data into important and core categories. Anything that could endanger national security is subject to Level 4 security requirements and must be stored within China. There are even fears that two-way communication in batteries could be used for espionage or remote disruption, leading to a new era of cyber-governed energy. The economic stakes are massive. China's energy storage market is projected to reach $170 billion, with a value of $6 billion by 2025. In India, energy storage installations are expected to surge tenfold by 2026. The AI-optimized battery is no longer just a luxury, it's the cornerstone of the modern resilient grid. Whether it's the 12% energy cost reduction seen in Masdar City or the 50% reduction in manufacturing prototype cycles achieved by CATL, AI is the differentiator. As we move towards solid-state technology and higher energy densities, the ability to store, manage, and dispatch power with millisecond precision will define the winners of the 21st century energy landscape. The energy transition isn't just about changing our fuel, it's about upgrading our collective intelligence. If you want to stay on the cutting edge of the tech actually changing the grid, subscribe and hit the bell. Let us know in the comments, how soon do you think your home will be part of a virtual power plant? Thanks for watching.